Breast cancer is one of the leading causes of death among women worldwide, and it has been confirmed that early detection and accurate diagnosis of the disease can ensure long-term patient survival. According to the World Health Organization, 1/3 of the cost of cancer treatment can be reduced if the disease is detected and treated early. Methods for the diagnosis of breast cancer have become increasingly computerized, and in this project, I created a decision tree that can diagnose the cancer based on a variety of features that describe the mass present. This program uses a combination of parameters which describe the cell nuclei in a fine needle aspirate or FNA image of a breast mass, including the radius, compactness, and the texture. These parameters can help in making a classification that determines whether or not an individual has cancer. The dataset that I used in this project was the Wisconsin breast cancer dataset, which contains data from 569 individuals. In order to make such a classification, I needed to use a decision tree. A decision tree is a type of classification data structure which is much like a flowchart. A decision tree has three main parts. These three parts are root node, internal nodes, and leaf nodes. Let's start with the root node. The root node is the node at the top of the tree, and it has arrows pointing away from it, but no arrows pointing towards it. This node is typically the node that separates the data the best. The next type of node is an internal node. Internal nodes have arrows pointing towards them and away from them. And the last type of node is a leaf node. Leaf nodes have arrows pointing towards them, but no arrows pointing away from them. A leaf node contains an outcome or a classification for a particular sample. No leaf node can 100% accurately classify all of the samples, so we call these nodes impure. A common and very popular method of measuring the impurity of a sample is the Gini impurity, which is named after the Italian statistician Corrado Gini, and it can be calculated like this. The smaller the Gini impurity of a node, the better it is at classifying samples, so the root node is typically the node with the smallest Gini impurity. By calculating the Gini impurity of all of the samples, we can create an optimal decision tree. This is a decision tree that I made by using scikit-learn. And this is the root node, these are the internal nodes, and these are the leaf nodes. Each data point goes down the decision tree cascade until it gets to a leaf node, which has an output. Each data point would be asked questions pertaining to the qualitative features of the cell nuclei in the mass in order to determine if it is malignant or not. In this case, the data point would be asked by the program if the texture is less than or equal to 3.5, and if yes, it would go to the left, and if no, it would go to the right. Let's say that in this case, the texture was indeed less than or equal to 3.5. The program would then ask the data point if the compactness was less than or equal to 2.5, and so on until a leaf node is reached, at which point we would get a classification of either 2 or 4, where 2 indicates that the individual did have cancer, and a 4 indicates that the individual did not have cancer. Each individual node, including the root node and internal nodes, also contains a classification, but the impurity of these nodes is very high. So this shows that the accuracy of classification increases as more data is considered. In the original dataset of 569 samples, 65.01% of the individuals were positive for cancer, and the remaining 34.99% of individuals were negative for cancer. My program was able to classify these samples with 97.3% accuracy. Hence, by using the features of the cell nuclei, a prediction about the malignancy of the mass can be made by making a decision tree in scikit-learn. This could help doctors in verifying their diagnoses and could aid them in making important decisions.